Hello, everybody. Here we are, Chapter 8, and 8.1 is Systems of Linear Equations and Graphs. I typed out the notes for you, so it's a little bit easier to read, and it's just a little bit of definition of what a system of a linear equation is. So the first one, does introduced some problems already, but it's a collection of one or more linear equations involving the same set of variables. For the most part, we're going to see two or more. They might have, one solution, no solutions, or infinitely many solutions. That's when we have kind of one linear equation. And so please write this down. Maybe I'll give you a pause so that you can write it all. But a solution for a system of linear equations is where the values of the variables make all equations true at the same time. I think this definition we'll see a little bit just as we go through the examples. But graphically, I feel like it's easier when we talk about graphically to understand what the solution is. A solution is where the two or more linear equations meet. So our first questions will deal with showing it graphically, the solution. But you might also see the solution as like on a data set or on a table of values where the two are identical. That's a solution for that system of linear equation. So I think once we get working with it, these definitions will make a little bit more sense. Hopefully I've paused it and you've had time to write this down, and let's get into it. So number one, solve each system of linear equations graphically. So let's graph each of these, and the point at which they meet will be a solution. So let's graph them. They're both in slope-intercept form, so that's great for us. Our first one, we have a y-intercept of +1, so we've got a dot there. And then our slope, our rise over run is 3/1. So let's go up 1, 2, 3 and run 1. It's positive, so we're going to be moving kind of like a check mark. Go 3, 1. Let's go down the other way just in case we find ourselves that way. I'm not going to connect them. The part that I don't love about sometimes connecting it or these types of solutions is your line has to be very exact for the solution to be obvious. These ones we're going to have a dot where they meet. So I won't connect them for now because maybe that'll make the solution slightly more easy to see, but your line has to be very straight sometimes to see the solution. Let's do the next one. I'll do it in red. We have intercept of 8. 1, 2, 3, 4, 5, 6, 7, 8, positive 8. And then our slope, -1/2. So let's do it as -1/2. So we're going to go down 1 and right 2. There you go. So you can see we've already now found our solution. It's this dot right here where they both meet, but I'll put a couple more dots on there just in case, just for fun. So down 1, 2, up 1, like that is what our other line is going to look like. And this dot where they both, they each have a dot exactly there is our solution. So that looks like that's at 2, 1, 2, 3, 4, 5, 6, 7. 2, 7 seems to be the solution for the system of linear equations. So I'll write that down. Our solution is at 2, 7. And then I'll show you what this means. This means that if we input 2 and 7 into each of our equations, that our equation will be true. So is it true that for our first equation, 7 equals 3 times 2 plus 1? Is that true? Is it true that 7 equals 6 plus 1? And I would say, yes, it is true that 7 equals 6 plus 1. So it's true for one of our equations. And now we want to see, is it true for the other one? And that will make that a solution for both of them. So is it true that 7 equals -0.5 times 2 plus 8? Is that true? Is it true that 7 equals -0.5 times 2 gives us -1 plus 8? Is it true that 7 equals -1 plus 8? Yes, that's true. So we know we did that one correctly. So a solution is a point of coordinates that make both of our linear equations true at the same time. Okay, let's do our next one. We're going to do a little bit of converting to slope-intercept form. I think that's easiest to graph. Here we have a positive y, and there's no coefficient, so that's easy. We can subtract the 2x from each side. We'll get y equals negative 2x plus 2 for our first line. And this one we have a negative y, so I'd want to move that guy over, and we're going to move the 7 over the other way in the meantime. So we'll have a positive y equals x subtract 7. So there's our 2 in slope-intercept form, and now let's graph them. Do the top one, we got a dot at positive 2, that's our y-intercept. Then a negative slope, so we go down to right 1, down to right 1. Let's go the other direction, and let's go 1 down that way. And then our other line, we start at negative 7. 1, 2, 3, 4, 5, 6, 7. And then we're going to go positive slope, up 1, right 1, like this. And then you see, okay, we have now a solution. Let's do another dot the other way of our blue. And so we have a point where they meet. We have a point on each of our lines where they intersect. And that is at, looks like 1, 2, 3, negative 4. So our solution where they meet is at 3, negative 4. And then let's see if we did it right. Let's see if it makes both of these true. So is it true that negative 4 equals negative 2 times 3 plus 2? So I could have done it at either point in our equation. Maybe it actually would have been easier to do it in our original form, but it doesn't really matter. Is it true that negative 4 equals negative 6 plus 2? Is that true? And I would say yes, that is true. So we know that to be a solution for our first line. And then the next one, I guess I'm using the slope-intercept form, so let's do it. Is it true that negative 4 equals 3 subtract 7? And I don't think I need to do the next step here. I think we can see that it is true that negative 4 equals 3 subtract 7. So yes, we verified that this is a solution for each of them. This is the point at which they are both true. Okay, sometimes we will have some word problems, and it's good to be able to pull out the equations from it. And sometimes it's going to ask you to solve them, and sometimes it's not. This one, it says, can you solve it? I think that's an invitation to solve it, so let's do it. But often we need to, what they're asking us to do is just pull out the equations, just find the linear, the system of linear relations, and not always solving it. But this one we are going to solve it. So Ben is 2 years older than Angela. They usually kind of give you two pieces of information that we're going to make two equations out of. The sum of Ben and Angela's ages is 34. So create a system, a linear system to model this situation, and can you solve it? So you have two pieces of information. Often, you're going to do something like let B equal Ben's age, and let A equal Angela's age. And what we know is that B, Ben's age, he's 2 years older than Angela. So we know that B plus 2 equals A. Okay, that's that one right there. Ben is 2 years older than Angela. So whatever Angela is, Ben's got 2 years on her. And the next one, we know that the sum of Ben and Angela's names, we add them together, they equal 34. Okay, so there is our linear system right there. We have two equations, two pieces of information. And this one, we could graph it. I'm actually going to make a table of values. And we'll see there's going to be a line. Spoiler alert, there is a solution for this. We're going to see a part at which both of the coordinates are the same. So let's do B and A, and let's do B and A over here. This can be our B plus 2 equals A. 2 years older than Angela. Wait, I think we need to do it the other way. Ben is 2 years older than Angela. Okay, sorry, let me swap these two here. So it's actually Angela plus 2 equals Ben. Okay, that's my bad. I'm going to swap these two then. So let's go Angela, Ben, Angela, Ben. Okay, Ben is 2 years older than Angela. There we go. Okay, so if Angela is 1, Ben is 3. And if Angela is 2, Ben is 4, 2 years older. And these, I mean, let's do a few of our other ones. Their ages need to equal 33. So if Angela is 1, the Ben would have to be 33. They need to equal 34, sorry. And 2, would need to be 32. We're not really anywhere near those, so I'm going to skip ahead a little. I'm going to go dot, dot, dot here and a dot, dot, dot there. We need them to be much closer in age, I think, to satisfy both of these. So let's try, Angela being 15. That means Ben is 17, so he's 2 years older. But this only adds up to 32. If we have it right here, if we have Angela at 15, to equal 34, Ben would need to be, Ben would need to be 19. And the next one, if we do 16, Ben is 2 years older, we have 18. And that seems like a good place to start. I mean, let's do one more, 17 and 19. But let's do our next one. If we have 16, what we would need to do to equal 34 is also 18. And we see that's where our 2 points are identical. So we have a solution at 16 and 18. So solution, 16, 18 years old. Okay, so it's true that A plus 2 equals Ben's age, and it's true that A plus B or B plus A equals 34. So that's our solution for that one. Let's do the next one before my pen runs out. The total area of both lots is 225 meters squared. The larger area is twice as big as the small area. Okay, so create a linear system to model the scenario. So we know that the large lot plus the small lot equals 225. And we know that the large area is twice as big as the small area. So 2 times the small equals the large. Okay, so there is our linear system right there, that the total area of the lots, so them, added together equals 225. And the larger area is twice as big as the small area. Okay, and now B, verify that 75, 150 is a solution to the system. So we just need to say, is it true that if we substitute these in, that they are going to make both of these true at the same time? So is it true that 150, our large lot, plus our small lot, 75, equals 225? Is that true? And yes, indeed, I would say it is true that 225 equals 225. So yes, that works for our first one. And the next one, is it true that 2 times 75, our smaller lot, equals, let's keep doing that, equals 150? So is it true that 2 times 75 equals 250? And it is true that 150 equals 150. So there you go. We verified that that is a solution to this linear system. And thank you so much. I'll tell you what textbook questions I'd like you to do.